Okay, so good day everyone. My name is Harry Surigao. Welcome to Refrigeration and Air Conditioning. So, there are steps or process in cutting piping. First is cutting tubing, bending tubing, making flare joints, and swaging. So, what is the purpose of tubing and piping? So the purpose of tubing and piping is to provide the path for refrigerant flow between system components. It also provides the way for oil to drain back to the compressor. So tubing, piping, and fittings are used in numerous applications such as fuel lines for oil and gas, burners, and water lines for hot water heating. So the tubing, piping, and fitting must be of the correct material and the proper size. So the system must be laid out properly and installed correctly. So first process is cutting tubing. So first, you have to place the tubing in the cutter and align the cutting wheel, the cutting mark on the tube. So tighten the adjusting screw until a moderate pressure is applied to the tubing. So when properly tightened, the cutter should be held in place. Indentions on the tubing, and there should be no cutter wheel indentions in the copper tubing. So over tightening the cutter and the tubing will result in oblong or out of round edges that can cause refrigerant leaks. So second, revolve the cutter around the tubing. So keeping a moderate pressure on the tubing by gradually turning the adjusting screw. So next, continue until the tubing is cut. Do not apply excessive pressure because it may break the cutter wheel and constrict the opening in the tubing. So letter A, B, C, figure 7.11. So please refer to the picture. So next is when the cut is finished, excess material called a bar pushed into the pipe by the cutter wheel must be removed. Bars cause turbulence and restrict the fluid or vapor passing through the pipe. So be sure to clean the pipes because there are some bars that can cause turbulence and restrict the fluid or vapor passing through the pipe. So when removing bars from the end of cut pipe section, make every attempt to prevent the bars from falling into the pipe. So bars that remain in the system can restrict refrigerant flow and affect system operation and performance. So next process is bending tubing. So to ensure the refrigerant stays in the system, the number of solder joints and mechanical fitting should be kept to a minimum. So each solder joint, fitting, and mechanical connection represents a potential leak. One way to reduce the number of solder joints in a piping system is to bend the tubing like what is shown in the picture. Oops, sorry. So letter A and B. And typically, only soft tubing should be bent, not the hard one. So use as large a radius bend and possible. So carefully bend the tubing, gradually working around the radius. And tube bending springs may be used to help make the bend. So please refer to figure 7.14. The man holding this one. It is just like a spring, and it is used to bend the tube in any desired degrees. and can be placed either inside or outside the tubing. So they are available in different sizes for different diameters of tubing. So then to remove the spring after the bend, you might have to twist it. You have to twist if you use a spring on the OD. Bend the tube before flaring so that the spring may be removed. Here in figure 7.15, here are different size bending springs. It differs on the size of the tube. Then lever type tube benders. Here is some other bender which are available in different sizes. This is used to bend soft copper, aluminum, and thin-walled steel tubing. So there are many different types of benders available. So we describe briefly here the operation of the lever type bender. The lever type bender is made up of two parts. The body and lever. Here, the upper part, and the lower part is the body. Then, if however you wanted to make a 45-degree bend in the tubing instead of a 90-degree bend, the lever would be positioned so that the 0 degree on the lever is lined up with the 45 degree on the body. 7.21, the lower part picture. So be sure to practice on smaller scrap sections of tubing to gain confidence in creating tubing bends at the desired positions. So it takes a time to get it just right, but the result will be worth the effort. So in order to bend perfectly, you have to practice and you can use a scrap tube so that your actual tube will not be damaged. Then next process is making flare joints. So this is another method of joining tubes and fitting is the flare joint. A flare on the end of the tubing is made against an angle on a fitting and is secured with a flare nut behind the flare on the tubing. So the flare on the tubing can be made with a screw type flaring tool using the following procedure. First, cut the tube to the right length. Second, to remove all bars and clean all residue from the tubing. So we have already knew what are bars, right? So bars should be removed before proceeding to the next process because it may damage your tubes. There might be a turbulence as the process go. So next, slip the flare nut or coupling nut over the tubing with the threaded end facing the end of the tubing. Next, clamp the tube in the flare block. Figure 7.50, letter A. Here. Adjust it so that the tube is slightly above the block or about 1/3 of the total height of the flare. So next, place the yoke on the block with a tapered cone over the end of the tube. Letter B. So many technicians use a drop or two of the refrigerant oil to lubricate the inside of the flare while it is being made. So next, turn the screw down firmly. So letter C. Tighten and loosen the screw several times during the flaring process to prevent the work from hardening. So continue until the flare is completed. Next, remove the tubing from the block on letter D here. Inspect for defects. If you find any cut off the flare and start over. Then last procedure on flaring is assemble the joint. Last process is swaging techniques. So swaging is not as common as flaring, but you should know how to make a swaging joint. Swaging is the joining of two pieces of copper tubing on the same diameter by expanding or stretching the end of one piece to fit the other so that the joint may be soldered or brazed. So there are two ways to join these swaging techniques. It's either solder or braze. Here, the unjoined copper tubes and the joint tubes, the upper one and the lower portion. So as a general rule, the length of the joint that fits over the other is equal to the approximate OD of the tubing. So you can make a swage joint by using a punch or a lever type tool to expand the end of tubing. So here, a swaging punch, this letter B. Then place the tubing in a flare block or an anvil block that has a hole equal to the size of the OD of the tubing. The tube should extend above the block by an amount equal to the OD of the tube plus approximately 1/8 inch here in figure 7.55 letter A. Place the correct size swaging punch in the tube and strike with a hammer until the proper shape and length of the joint has been obtained. And figure 7.55 letter B, follow the same procedure with screw type or level type tools. A drop or two of refrigerant oil in the swaging tool will help, but it must be cleaned off before soldering. So next, assemble the joint. The tubing should fit together easily. So always inspect the tubing after swaging to see whether there are cracks or other defects. If any are seen or suspected, cut off the swage and start over. So here are some tips to help ensure that the swage is correct, neat, and straight. So if using a swage punch, rotate the flaring block 180 degrees every 3 or 4 strikes. This will keep the tubing on the other side of the block straight as the swage is formed. Next, do not tap the swage punch from side to side with a hammer. This will expand the swage too much and space between the mating surfaces will be too large. Avoid placing the flaring block in a vise to hold the tubing while striking the swage punch. So that's it for today. So I hope you'd learned a lot for our topic. So thank you and God bless.